In this video, I'm going to show you how I completed day 2 of the Advent of Code 2023. I think this is a good demonstration of test-driven design. Test-driven design is an approach where we develop tests for our system and then only write the code needed to make the tests pass. This lets us really focus on the functionality of the system before being bogged down by the minute details of the implementation. This also works really well when you have a very well-defined input-output, but don't know immediately how to approach solving the problem. I encourage you to read the prompt yourself, but to summarize, essentially what we have is a bag of cubes. The cubes can be one of 3 colors, and there is an unknown quantity of cubes in the bag. We get to see multiple random samplings of the bag, but never the whole contents. Then we have to determine if, based on the random samplings, it would have been possible for the bag to contain a particular set of cubes. On screen, you can see me just reading the prompt and gathering my thoughts. I eventually realized that determining if a game is possible simply means checking if too many cubes were shown. I make a note that the algorithm looks very straightforward, but it feels like a trap, so I want to make sure to put good thought into the data structures that we'll use, because I'm sure in part 2 something's going to change, and if too much of the algorithm is hard-coded, then it may be difficult to modify. Here you can see me thinking about those data structures and how we might parse them. I also note here that the order in which the colors have appeared is inconsistent, so that's one thing we won't want to have hard-coded. Then I get into actually writing the code. After putting placeholder text in main, the very first thing I do is start creating a unit test. I'm going to be writing the test before any of the actual code. The test I'm writing is going to replicate the example from the prompt. The first thing I need to do is be able to create a data structure containing the information about cube quantities. I just write that in my test as if it already exists, and afterwards I go make the actual class so that the test compiles. I called that class a handful, imagining that you pulled a handful of cubes out of the bag. I repeat the same process for defining a full game, which is an ID and a list of these handfuls. Then I complete the test by calling the not yet existing isPossible function and asserting that it should be true. That concludes writing the first test, so now I go implement the logic to make it pass. Making this test pass is easy because all we have to do is make the isPossible function just always return true. I then start writing more tests based on the example input. Game 1 and 2 both pass the tests, but once we get to game 3, which is supposed to be impossible, the test fails. Now that I have a failing test, I start writing just enough code to get it to pass. What I notice is that to determine if a whole game is possible, I have to know if an individual handful from the bag is possible. So I write a test for that. Once that test is written, I add the functionality to my handful class, and this naturally bubbles up into the game class, where we now have the tests passing. At this point, the behavior of the system is mostly working, but we have no way of parsing the input. So the next step is to figure out how to go from the strings that the website gives us to the objects that my application processes. It wasn't immediately obvious how I should structure this parser in the code, so I went back again to test-driven design. Partway through writing the parser test for the whole input string, it clicked for me that I need to be able to parse the subset of the input that just defines a single handful. So I write a test for that and tackle that first. I decided I'll use regex to extract the info from the string. I remembered from the beginning that I had to not assume the order of the colors, so I went with 3 individual regexes, and I used the info from the regexes to build the handful object, and after fixing a typo in the regex, the test passes. I spent a while trying to come up with one single regex that would capture both the game ID as well as each of the handfuls, until I eventually remembered the technique I had just used of writing separate expressions. I use one expression to get the game ID and a second expression to match the handfuls. With the proper regexes in place, I can parse a full line of input into a game object. I wrap up the test I had been writing, and now we have a functioning parser for one line of input. The next test is essentially a full end-to-end test, which loads the input as a string and gives you the output that the prompt is expecting. With the test passing on the full example input, we finally begin actually writing the main function of our program, which simply loads all the lines from a text file and gets the possible games and sums them up. And it works first try. Continuing on to part 2. Rather than determining if a game is possible with some particular set of dice, we now need to determine the smallest set of dice for which the game is possible. Additionally, we have to change our summing technique to be the product of all the dice rather than the sum of the game IDs. The very first thing I do is create a new unit test, which is going to test the new summing technique. This introduces a function to get the minimum set of cubes and introduces the power property of a set. Once that test was in place, I realized there was a smaller unit that I could test, which is just the function to get a minimum set. So I wrote that test. I implemented the method to get the minimum set and expected everything to pass, but then I saw I forgot to implement the power property. Once that was implemented, all the tests were passing again. With the tests passing for the example input, it was now only 2 lines I needed to add to the main function to have the new answer calculated. Thanks for watching, and if you're interested in the source code, I have my GitHub linked in the description.